Hello, my dear students. Welcome to science class. So, today we will be starting with a new chapter, that is chapter number 13, Fun with Magnets. It's a very interesting chapter. So, let's see what we are going to learn today. Today, first we will be learning about a short introduction on magnet and magnetism. Then we will be learning about how the magnets were discovered. That is a short story on discovery of magnet. Then we will be learning about magnetic and non-magnetic material, followed by types of magnet, then magnetic field, magnetic poles, and properties of magnet. Okay, so let's begin with magnetism. So what is a magnet? A magnet is an object which attracts things made of iron, steel, nickel, and cobalt. Okay. Here you can see this is a U-shaped magnet. Okay. And it is attracting a paper clip which is made up of what? Which is made up of steel. Okay. And since it is made up of steel, so therefore steel, it is getting attracted to the magnet. Okay. Now these magnets, okay, they are made up of iron, steel, or other alloys of iron by the process of magnetization. Okay, so magnets which are made by the process of magnetization is known as what? Is known as artificial magnet. Okay, that is the man-made magnet. Okay, and the magnets which are found naturally, those are known as the natural magnet. Okay, so there are many shapes and sizes of magnet that I'll discuss later. Before that, let's start with the story that how the magnets were discovered. Now, there is an old story that magnets were discovered by chance by an old shepherd named Magnus who lived in ancient Greece. Okay, now this person, Magnus, used to take his herd of sheep and goats to a nearby mountain for grazing. As you all know that goats and sheep are herbivores. Now, while taking his herd of sheep and goats to the mountain, he always took a wooden stick with him to manage his herd of sheep and goats. Okay. Now, this wooden stick, it has an iron casting on its lower end. So one day, Magnus suddenly felt that something was pulling his stick away from him. Okay, it appeared that as if iron covered end of the stick was being attracted by rock and got stuck to the rock. Right? Now Magnus had to pull hard to free the iron end stick from the rock. Actually, the rock was the natural magnet which attracted the iron end of Magnus stick. Right? Now, this rock, okay, which behaved like a magnet, was given the name magnetite. The magnetite rock, it contains iron. Right? The magnets were named so after the name of the shepherd, Magnus. Right? Now, some people, however, believe that the natural magnet, that is magnetite, was first discovered at a place called Magnesia in Turkey. Okay, and this is how the natural magnets were discovered. Okay. Now, one more thing I need to say you about this magnetite rock, that this magnetite rock had some wonderful properties. That is, the magnetite attracted the piece of iron towards itself, and when a thin strip of magnetite was suspended from a thread so that it can rotate freely, the magnetite string always aligned itself in the same direction. That is north-south direction. Okay, that one I'll teach you when I'll explain you about the properties of magnet. Okay. Here you can see this is what this is actually the magnetite. Okay, this is actually the magnetite or the lodestone. Okay, its chemical composition or molecular formula is Fe3O4. Okay, and it is found in many countries. Okay, now next comes the magnetic and non-magnetic substances. Okay, now, suppose if you keep iron nail, paper clip, brass screw, then aluminium foil, plastic comb, coin, sewing needle, piece of paper, copper wire, pieces of thermocol, okay, on a wooden table, okay. And if you bring, suppose, a bar magnet or any kind of magnet towards it, what you will find? You will find that iron nail, then paper clip, as because it is made up of steel and steel, it is an alloy of iron. Sewing needle, they are getting attracted by the magnet and hence they are sticking to the Okay, but rest of the things like a piece of paper, then brass screw, aluminum foil, plastic foam, okay, then thermocol, they are not getting attracted by the magnet. Okay, they are left behind, right? So what is a magnetic material? Those material which are attracted by a magnet called magnetic material. Okay, examples, what are examples? Iron, steel, nickel and cobalt. Okay, iron, steel, nickel and cobalt, these are the magnetic material. Okay, and most common and important magnetic materials are what? Especially iron and steel, and any object which is made up of iron and steel like nails, paper clip, sewing needles and hairpins, paper pins, drawing pins, safety pins, knife blades, scissors, paint. Okay, all these are also but magnetic substances, right? And what are non-magnetic material or non-magnetic substance? Those materials which are not attracted by a magnet are called what? Are called non-magnetic material. Examples, there are many examples like wood, plastic, rubber, paper, cloth, glass, leather, thermocol, copper, aluminum, brass, lead, stone, diamond, graphite, then charcoal, air, water, sun, bones, etc. All these are what? All these are the non-magnetic material. Why? Because they are now attracted by magnet. In fact, most of the materials around us are non-magnetic material, and even anything which is made up of this non-magnetic material, they are also what? They are also non-magnetic material. Like suppose I mean to say, if wood is a non-magnetic material, so a spoon, ice cream spoon, which is also made up of wood, that also behaves as an non-magnetic material. Okay, but a steel spoon side by side, it is what? It is a magnetic material as because it is made up of steel. Okay, and non-magnetic material, they cannot be magnetized to form the magnetic material. Okay. Now, types of magnet. How many types of magnets are there? Two types of magnets are there. Number one is the natural magnet. Okay. Example is magnetite and lodestone, and artificial magnets are the man-made magnet. Okay. They have got a strong magnetic power. Okay. And they are found in what? They are found in different shape. Okay. Now, one more thing. What are the, if anyone asks you that what are the use of magnetic material? The use of magnetic material. Now, one common example I'm giving you. Suppose you are carrying a pin box, okay, paper pin box, okay, and there are large number of pins in a pin box, and suddenly or accidentally all the pins have fallen on the floor and it got scattered, okay. Now, if you try to collect these pins one by one, okay, it will take a lot of time, okay. Now, like instead of picking up each and every pin by hand, if you just take a magnet and if you move a magnet over the pin scattered on the floor, then what will happen? All the pins will be attracted to the magnet and stick to it. Okay, so it has made the work easier. Similarly, like if a carpenter, okay, while cutting the logs of wood, okay, if the carpenter has mixed some iron nails and screws with lots of wood shavings while working, so you can help him getting back the nails and screws from the wood shavings by using a magnet. How come? If you move a magnet through the wood shavings containing nails and screws, then what will happen? The nails and screws will be attracted to the magnetic stick into it. Okay. Now wood shavings, since they are non-magnetic and so they will not stick to the magnet. Okay. These are the artificial magnet. Okay, this is the bar of the bar magnet. Okay, this is a U-shaped magnet. This is compass. Okay, here you see this one is the button magnet. This one is a button magnet. This is a ring magnet. This is a cylindrical magnet. Okay, so these are the different shapes and sizes. Okay. Here you see horseshoe magnet. Okay, this is bar magnet, and always remember magnets have got two poles, north pole and south pole. Okay, these are the magnetic needle. Okay, and this is what? This is a disc shaped magnet or button magnet. Okay, now what is a magnetic field? The area surrounding the magnet in which magnetic force is exerted to attract iron is called magnetic field. Now suppose a magnetic material, for example, suppose you are sitting here, you have got a magnetic material onto your hand, and suppose the magnet, okay, the magnet is located suppose around 10 centimeter away from you. Okay, so in that case the magnet, it will not attract. Okay, but if you just bring the magnetic substance closer, now at a particular point you will find that the magnetic substance is getting attracted to the magnet. Okay, so the area or the surrounding, okay, the magnet, okay, where the magnetic force is exerted to attract iron, that part is known as what? That part is known as the magnetic field. Okay, here you see this is the magnetic field. Okay, so these are the blue lines. This is the magnet. It has got two poles, north pole and south pole, and these blue lines, it indicates what? It indicates the magnetic field. Okay, next comes what? Next comes the poles of a magnet. Okay, poles of a magnet. Now, suppose this is a bar magnet. You all know that this is a bar magnet. Now, if a bar magnet, if it is put into a heap of iron filings, then what will happen? The iron filings will cling to it or stick to it. Okay. Now, the maximum amount of iron filings, where you will find that they are getting attracted on the two ends of the bar magnet. Okay. So this shows that the force of attraction of the magnet, it is strongest near two ends of the bar magnet. Okay. So these two ends of the bar magnet are called what? Are called the poles of the magnet. Okay. Now actually what are the poles? Poles are the places on the magnet, okay, where pull of the magnet is the strongest. Okay, so how we can define the pole of a magnet? The region of a magnet where the attraction of the magnet is strongest are called what? Are called the poles of a magnet. Okay, now poles, there are two types of pole. That is, number one is the north pole and another one is the south pole. Okay, north pole, it is represented by the letter capital N. Okay, and south pole, it is represented by writing the letter capital S on the other end. Now, North Pole and South Pole of a magnet always exist together. Every magnet, okay, whether it is a big or small, it has a North Pole and South Pole. Okay, and it is impossible to have a magnet having only one pole. Okay, now though the maximum amount of iron filings stick on the two ends of the bar magnet, some of the iron filings also you will find they are getting attached to the middle part of the bar magnet. So what does it show? It shows that some force of attraction also exists in the middle part of the bar magnet, but it is very small. Okay. So what are the properties of the magnet? Number one, they attract magnetic material, as I said you. Then number two, a freely suspended magnet always rests in north-south direction. Okay, a freely suspended magnet. These are the properties of magnet. Like if you hold a magnet with a thread and if you just freely suspend it without any support, what you will find? You will find that they are always existing or resting in the north-south direction. That I will explain in the next class along with an experiment. Okay, and like poles repel and unlike poles attract. What are like poles? Suppose north pole, they repel. Okay, south pole, they repel. But north pole, if it is facing towards the south pole, they attract. Okay, in details about this we will be explaining in our next class. Okay, here you see. This is like pole, that is north pole, they repel. Okay, but south pole and north pole, they are unlike pole. They always attract to each other. Okay, here you see this picture, it shows clearly. North pole and south pole, they attract. South pole, north pole, they attract. North pole, they always repel to each other. South pole, they always repel to each other. That is, unlike poles, here you see, they gets attracted, and like poles, they gets repelled. Okay, so that's all for today. In our next class we will be learning about an experiment that a freely suspended magnet always points in north south direction. Then we will be learning about what? About compass. Okay, that is how the magnets are used to find the direction. Okay, so thank you everyone. Stay home, stay safe.